Hello students, in this class we will learn about symmetric and skew symmetric matrices. Okay, and then some relationships which are related with a symmetric and a skew symmetric matrices. Okay, so let us study what do you mean by symmetric matrix and skew symmetric matrix. If A is a square matrix and A transpose is equals to matrix A, then matrix A is known as a symmetric matrix. Okay. If A is a square matrix and A transpose is equals to matrix A, then matrix A is known as a symmetric matrix. Okay. So A transpose is equals to matrix A, imply Aij is equals to Aji. Okay. That is why for a symmetric matrix we can take an example. If matrix A is equals to A Hg Hbf Gfc, then A transpose is equals to, this first row will be the first column A H G, the second row will be the second column H B F, this third row will be the third column G F C, and this is same with this matrix A. That is why we can write A transpose is equals to matrix A. Okay. Imply matrix A is a symmetric matrix. If we follow this matrix A, then this is the element whose position is first row and second column. That means here A21 is equals to 8 and A, this is the element of first row and second column. That means A12 is equals to 8 and this is the element of second row and first column. That means A12, it is also 8. This is the element of second row third column. That means A23 is equals to F, and this is the element which lies in third row and second column. That means A32 is also F, That means A12 is equals to A21. This will be A21, that is element of second row and first column. So A12 is equals to A21, A23 is equals to A32. Okay, that means these relations, this matrix follows this relation, that is Aij is equals to Aj. So symmetric matrix is a matrix, is a symmetric matrix is a square matrix when its transpose will be same with the given matrix. Okay. Now skew symmetric matrix. If A is a square matrix and A transpose is equals to minus A, then matrix A is known as a skew symmetric matrix. Okay. If A is a square matrix and A transpose is equals to minus A, then matrix A is known as a skew symmetric matrix. That is, in this case, Aij is equals to minus Aji. Okay. So let us take an example. Matrix A is equals to 0 H minus F minus H F 0 B 0. If we observe this matrix A, then its diagonal elements are 0. By following this relation, when I equals to j equals to 1, then we get A11 is equals to minus A11. These imply twice of A11 equals to 0. These imply A11 equals to 0. Okay. Similarly, A22 is equals to 0 and A33 is also equals to 0. That is why in matrix A, diagonal elements are 0. Now, A transpose is equals to 0 H minus F minus H 0 B F minus B 0. Taking minus 1 as the common factor from all these elements, we get minus of 0 H minus F minus H 0 B F minus B 0. This is same with matrix A. The 0 H minus F minus H 0 B F minus B 0. So that is why we can write A transpose is equals to minus A. So matrix A is an example of a skew symmetric matrix, and in case of skew symmetric matrix always we have to follow this relation, that is Aij is equals to minus Aji, and by following this relation we get the diagonal elements are 0. Okay, so we learned about symmetric matrix and skew symmetric matrix. A square matrix A will be a symmetric matrix if A transpose is equals to A, and a square matrix A will be a skew symmetric matrix if A transpose is equals to minus A. Okay. Now we will learn how we can represent a square matrix by the addition of a symmetric and a skew symmetric matrices. Okay. Let A be a square matrix and matrix A is equals to matrix P plus matrix Q, where P is a symmetric and Q is a skew symmetric matrices. Okay. So let A be a square matrix and matrix A is equals to P plus Q, where P is a square matrix and Q is a skew symmetric matrix. Matrices. So matrix A is equals to P plus Q. This is relation 1, and P transpose is equals to P, comma Q transpose is equals to minus Q, because P and Q are the symmetric and skew symmetric matrices. Now A transpose is equals to P plus Q whole transpose, imply A transpose is equals to P transpose plus Q transpose by the property of transpose, that is, since M plus N whole transpose is equals to M transpose plus N transpose. Okay. By following this property of transpose, we can write P plus Q whole transpose is equals to P transpose plus Q transpose. This imply A transpose is equals to P transpose is equals to P, because P is a symmetric matrix, and Q transpose is equals to minus Q because Q is a skew symmetric matrix. This is number 2. Solving relation 1 and 2, we get matrix P is equals to half into A plus A transpose, and matrix Q is equals to half of A minus A transpose. Okay, so thus we can write matrix A is equals to half of A plus A transpose plus half of A minus A transpose, where this will give a symmetric matrix and this will give a skew symmetric matrix. Okay, so this is the way by which we can represent a square matrix A by the addition of a symmetric and a skew symmetric matrix. Okay, as an example, we consider matrix A is equals to 3, 1, 5, 4, 7, 8, 9, 6, 2. We have to write this matrix A by the addition of a symmetric and a skew symmetric matrix. Okay. Solution. Matrix A is equals to, along first column 3, 1, 5, along second column 4, 7, 8, along third column 9, 6, 2. So therefore A transpose is equals to 3, 4, 9, 1, 7, 6, 5, 8, 2. Already we learned matrix A is equals to half into A plus A transpose plus half into A minus A transpose, where this will give a symmetric matrix and this part will give a skew symmetric matrix. Okay, so A plus A transpose is equals to 6, 5, 14, 5, 14, 14, 14, 14, 4. Okay, and A 6, 5, 14, 4, 14, 14, 14, 14, 4, and A minus A transpose is equals to 0, minus 3, minus 4, 3, 0, 2, 4, minus 2, 0. This is a symmetric matrix because A1, 2 is equals to A2, 1. A2, 3 is equals to A3, 2. Okay, that means transpose of this matrix is equals to this matrix, and this is a skew symmetric matrix because its all the diagonal elements are 0 and A12 is equals to minus A21. A23 is equals to minus of A32. Okay, that means transpose of this matrix will give negative of this matrix. That is why these are the symmetric and skew symmetric matrices. Now, matrix A is equals to 6 plus 5, 14, 5, 14, 14, 14, 14, 4 plus, half into, by following this relation, that is matrix A is equals to half of A plus A transpose plus half of A minus A transpose. 0, minus 3, 4, 3, 0, 2, 4, minus 2, 0. This is equals to 3, 5 by 2, 7, 5 by 2, 7, 7, 7, 7, 2 plus half into this matrix will give 0, minus 3 by 2, 2, 3 by 2, 0, 1, 2, minus 1, 0. So, this is the way by which we can represent matrix A by the addition of a symmetric and a skew symmetric matrix. This is symmetric and this is skew symmetric matrices. Okay, so in this class we learn about a symmetric matrix, a skew symmetric matrix, and the representation of a square matrix by the addition of a symmetric and a skew symmetric matrix. Okay.